It's not every day you hear someone casually say that the exciting thing to do would be to create an electric aircraft capable of vertical takeoff and landing, one that could also travel at supersonic speed. But when it comes from Elon Musk, it's never just talk. Imagine an aircraft that doesn't need a runway, one that simply shoots straight into the sky and cruises effortlessly through the clouds. That's the kind of vision Tesla is turning into reality. Brace yourself, because what's coming next might be the biggest disruption the aviation world has ever seen. Elon Musk's latest project, Tesla's brand new electric plane, it's officially entered the spotlight, and it's creating shockwaves across the industry. With an eye-catching price tag of just $99,999, this electric aircraft isn't just another futuristic prototype. It's the beginning of a new era of affordable, clean, and efficient air travel. For decades, private and small-scale aviation has been a privilege reserved for the wealthy few. Traditional aircraft often cost hundreds of thousands or even millions of dollars, not including the massive maintenance and fuel costs that follow. But Tesla's entry changes the equation completely. Using lessons learned from its automotive success, the company is now applying its revolutionary design philosophy to the skies, proving that electric propulsion, when scaled efficiently, can make aviation far more accessible and sustainable. Let's put things into perspective. A small piston aircraft can easily exceed $300,000, and even the most basic private jets soar past the $1 million mark. But Tesla's approach, offering an advanced electric plane for under $100,000, is a statement of intent. It signals the company's mission to democratize flight. In the same way, it made electric cars mainstream with the Model 3 and Model Y. The secret behind this aggressive pricing isn't a mystery. It lies in the power of electric propulsion. Conventional planes rely on engines that burn fossil fuel, require regular overhauls, and involve countless moving parts, all of which drive up maintenance costs. In contrast, Tesla's electric motors, refined through years of EV development, are far simpler, cleaner, and more durable. They deliver instant torque, creating a smoother and quieter flying experience, while drastically cutting down on upkeep, according to early estimates. Aircraft owners could save between $30,000 and $40,000 annually compared to operating a traditional light jet or piston engine aircraft. This dramatic reduction in running costs alone makes Tesla's offering a game changer. But that's only part of the story. The real breakthrough lies within Tesla's advanced battery technology. The aircraft is powered by the same 4,680 battery cells that are transforming its automotive lineup. These cylindrical cells, renowned for their superior energy density and faster charging capability, have now been re-engineered for aviation. The result? A plane capable of flying up to 700 miles on a single charge, rivaling many short-haul jets and small commuter aircraft. This kind of performance would have been unthinkable just a few years ago. But with battery efficiency and manufacturing costs improving rapidly, Tesla's electric plane becomes not just feasible, but practical. Add to that the potential for a dedicated aviation charging network, essentially superchargers for planes, and Tesla could eliminate one of the biggest challenges in electric flight: downtime. Imagine landing your aircraft, plugging into a high-speed charger for under an hour, and taking off again without the noise, pollution, or delays of conventional refueling. That's not just innovation, that's reinvention. Tesla's expertise in large-scale production gives it another major advantage. The company has repeatedly proven that mass manufacturing can drive costs down dramatically. If the same principle is applied to aircraft production, economies of scale could reduce the price of Tesla's electric plane to between $50,000 and $60,000 as volume ramps up. That's the same affordability revolution that took Tesla's cars from luxury niche items to everyday vehicles. For flight schools, entrepreneurs, or hobbyists who've long dreamed of flying but couldn't justify the cost, this development is nothing short of revolutionary. A sleek, high-performance, fully electric aircraft for under six figures could transform not just aviation as a business, but flight as a lifestyle. Now, let's dig deeper into the beating heart of this innovation: Tesla's 4,680 cells. These batteries aren't just an incremental improvement. They're a generational leap. Originally designed for Tesla vehicles, the cells feature a tables-as architecture that reduces internal resistance, improves heat management, and allows for more efficient power output. When adapted for aviation, those same traits become critical advantages: lighter weight, greater energy density, and higher reliability. In aviation, every pound matters. Weight reduction directly translates to longer range and better efficiency. By using these advanced cells, Tesla can store more energy per pound, enabling the aircraft to sustain flight for 4 to 6 hours while maintaining impressive range. For the average pilot, that means flying from Los Angeles to San Francisco or even farther on a single charge, all without burning a drop of fuel. Traditional piston engine aircraft not only guzzle aviation gas but also require expensive maintenance every few hundred flight hours. Engines need overhauls, fuel systems need calibration, and each part adds complexity and cost. Tesla's electric powertrain eliminates almost all of that. With fewer mechanical components and no fuel combustion, wear and tear is minimized, and downtime is drastically reduced. Tesla's history also proves that. Manufacturing breakthroughs drive down costs over time. Battery prices that once hovered near $100 per kilowatt-hour are now approaching half that. Thanks to vertical integration and process efficiency, experts predict that with continued innovation, Tesla could push costs even lower, perhaps near $50 per kilowatt-hour, a milestone that would redefine electric aviation economics. And as those costs drop, so will the aircraft's price. What starts at around $99,999 could eventually slide closer to $50,000, opening up opportunities for thousands of new pilots, air taxi services, and regional transport businesses. This isn't just a cheaper plane, it's the birth of a completely new aviation ecosystem. Charging infrastructure plays an equally vital role. Tesla's potential to build an aviation equivalent of its supercharger network could make electric flight more convenient than refueling with jet fuel. Instead of waiting hours for maintenance or dealing with complex fueling logistics, pilots could simply plug in, recharge quickly, and take off again. Such a system could revolutionize short-haul air travel, especially for regional commuting and cargo operations. The ripple effects of this shift would be massive. Lower maintenance costs mean smaller operators can thrive. Electric propulsion eliminates fuel volatility and emissions. Quieter operation means reduced noise pollution around airports and cities. For communities, it means cleaner air and a quieter environment. For passengers, it means smoother, vibration-free flights. Tesla's approach is holistic. It's not just building a plane. It's building an entire ecosystem, one that connects energy production, storage, and consumption seamlessly. Imagine a world where your aircraft charges using solar energy generated from your Tesla Powerwall, or where an electric vertiport seamlessly integrates with Tesla's charging stations. It's an ecosystem that closes the loop, from clean energy generation to clean transportation. When you combine these factors, affordability, technology, and scalability, Tesla's entry into aviation becomes more than just a business venture. It becomes a statement of what's possible when vision meets engineering. Excellence. Range and flight duration are perhaps the most crucial performance metrics for any aircraft, and Tesla's electric plane shines on both fronts. A range of 500 to 700 miles per charge places it squarely in competition with many short-haul commuter planes currently in service. That's enough to handle routes between major metropolitan areas, regional hubs, or even short international flights. This capability positions Tesla perfectly to tap into a lucrative segment of the aviation market. Regional air travel? Picture quick flights between cities like Los Angeles and San Francisco, New York and Washington, D.C., or Paris and London without the noise, emissions, or high ticket costs. For passengers, it means faster, cleaner travel. For operators, it means lower costs and higher margins. The plane's vertical takeoff and landing. VTOL capability adds another dimension entirely. With no need for long runways, Tesla's aircraft could operate from compact vertiports or even private properties. turning every major city into a potential launch point. This flexibility could decentralize aviation, allowing smaller airports and local communities to become hubs of air mobility. But beyond the numbers and specifications, there's something deeper happening here. Tesla's electric plane represents a new philosophy in design, one that blends environmental responsibility with technological advancement. It's proof that sustainability doesn't have to mean compromise. The aircraft promises high performance without pollution, accessibility without excess, and innovation without waste. Critics might question whether the world is ready for electric flight on this scale. But Tesla's track record suggests otherwise. When the company introduced the Roadster, few believed electric cars could compete with gasoline engines. When the Model S launched, skeptics doubted that battery vehicles could offer long-range or luxury appeal. And yet Tesla not only succeeded, it redefined both industries. Now, the same disruptive playbook is being applied to the sky. By tackling aviation's biggest pain points, cost, noise, emissions, and maintenance, Tesla's electric aircraft could pave the way for a new golden age of flight. It's not hard to imagine what comes next. A network of Tesla vertiports enabling regional air taxis, cargo transport powered entirely by renewable energy, pilot training programs that make flying accessible to a new generation, and perhaps in the not-so-distant future, larger electric aircraft capable of cross-country or even transatlantic journeys. Elon Musk's long-standing vision of sustainable transportation has always been about more than just cars. It's about transforming the entire ecosystem of movement, land, sea, and air. The electric plane is simply the next logical step in that journey. Of course, challenges remain. Energy density and batteries must continue to improve. Regulatory frameworks must adapt to electric flight, and infrastructure needs to scale. But Tesla has repeatedly shown its ability to overcome such barriers. Through relentless innovation, bold investment, and a refusal to accept the status quo, it has built the foundation for the next revolution in transportation. In the near future, we might see Tesla's sleek, whispered quiet planes lifting off vertically from compact urban pads, gliding across the horizon, and landing with zero emissions, offering the world a cleaner, faster, and more connected way to fly. And for anyone who thought aviation was an untouchable industry dominated by legacy giants, Tesla's $99,999 electric aircraft is a wake-up call. It's not just a product. It's a message that innovation knows no limits, and that the skies once reserved for the privileged few may soon belong to everyone, because in true Tesla fashion, the company isn't chasing trends, it's defining the future. The electric plane isn't just a machine. It's the embodiment of a new age of mobility. Affordable, sustainable, and undeniably revolutionary, it could very well mark the moment when flight itself is reinvented, not by an aerospace corporation, but by a company that started by building cars.